Good morning everyone. I am Nirmala. I am working as assistant professor in the Department of Computer Science and Engineering. Today I am going to explain about what is meant by this defect examples. Scenario 1. The software will allow the user to make the online payments using a debit card. Scenario 2. The software will help me in avoiding the spelling mistakes. So these are the examples of the defects and this is my problem statement. A simple specification, a detailed design description, and the resulting codes are shown. Defects in each are described. Software defect is a deviation from the requirement that causes the malfunctioning of a software. It does not necessarily mean a bug in the code. It can be any function that was specified in the software requirement specification document, but what was not recognized, developed, or implemented by the programmer. Defect. From the user point of view, typical examples of the software defects are as follows. Scenario 1. The software will allow a user to make the online payments using a debit card. Defect. The option of selecting the debit card for making the payments is missing. Scenario 2. The software will help me in avoiding the spelling mistakes. Defect. The feature of detecting the spelling error is missing. Three unusual types of the defects that restrict a software to perform in the conformance with its specifications. First one is latent defect. A latent defect is a hidden flaw in the software which is not identified by the user, although the developer or the owner is aware of it, until a set of operation is not performed. Example of the latent defect: an application to print the salary slips of the employees which provides the two different printer options to print in the drop-down menu, laser printer or dot matrix printer. Next, masked defect. Masked defect is a defect already existing in the software. However, it has not caused any failure in the application execution, mainly because it is covered or masked by the other defects. Example of a masked defect: as per the first instance where an application was not tested for the DMP, there are two main issues that have been masked: the DMP printer search and the DMP printer. The application always failed to select the laser printer, due to which the DMP printing mistakes were detected. As a result, DMP print remains hidden in the software. Defect cascading means triggering of the other defects in the application. Where the defect is not identified or goes unnoticed while testing, it invokes the other defects. As a result, multiple defects crop up in the later stages. In other words, it is a master defect which introduces many defects linked to it onto the future stages of the application lifecycle. Example of the defect cascading: an application has been deployed to calculate monthly salary of the employees. The module responsible for calculating the salaries is having an unidentified defect. Defect examples: the coin problem. It does not state that the input number of coins and the output, the number of dollars and the number of cents, should also have the values of the zeros or greater. The number of the coins cannot be negative, and the values in the dollars and the cents cannot be negative in the real world domain. As a consequence of these ambiguities and specification incompleteness, a checking routine may be omitted from the design, allowing the final program to accept the negative values from the input number of the coins for each denominations, and consequently it may calculate in an invalid value for the result. A more formally stated set of preconditions and post-conditions would be helpful here, and would address some of the problems with the specification. These are useful for designing the black box testers. A precondition is a condition that must be true in order for a software component to operate properly. In this case, useful precondition would be one of the states for the example: number of coins 0. A post condition is a condition that must be true when a software component completes its operation properly. A useful post condition would be number of dollars, number of cents is 0. In addition, the functional description is unclear about the large number of coins of each denomination allowed, and the largest number of dollars and the cents are calculated as output values. So these are the best example for the specification of calculated coin value. The program calculates the total dollars and cents for the set of coins. The user inputs the amount of pennies, nickels, dimes, quarters and half quarters, and dollar coins held. There are 6 different denominations of the coins. The program outputs the total dollar and the cent values of the coins to the user. Input: number of coins in an integer, number of dollars in an integer, and number of cents in an integer. That's it. Thank you.